Hi, I'm gonna go over the exercise on cut and paste for the material definitions, properties of materials and all of that. Hopefully you got this over email already and you would have had a try at this before doing it. Okay, so instead of cutting and pasting and making it too complicated, I'm just gonna draw lines matching the description with the word that we use to describe that. And so let's start with the beginning. It says returns to its original shape when the load is removed. So something that returns to its original shape we call something that is elastic. So I'm gonna draw a line going from here to elastic. Good. The next one was remains deformed when the load is removed. Sorry. So this is the opposite of plastic, really. When you take away the load, it stays deformed, and that's the definition of plastic. So for plastic, I'm gonna have to go around the top, probably. Yeah. So I'm gonna go from here to plastic. Let's see how we can do it. Go this way to plastic. Then let's see, cracks and breaks without plastic deformation. Something that cracks and breaks and does not deform plastically, that's something that doesn't have a lot of give. It doesn't absorb a lot of energy. So it's definitely not tough. It's the opposite of tough, which is really brittle. So brittle is something that cracks and breaks without plastic deformation. So let's see, I can do it here. Brittle is over there. So I'm just gonna go like this. Brittle. What else? Something that does not readily crack. It can withstand dynamic loads such as a shock or impact. So that's something that's the opposite of this, really. And so it can take a lot of a large shock or a large impact. That's something that's tough. So this would be something tough. Can be deformed plastically under tension and can be pulled into a long thin shape. So that's something ductile, right? If you're going to make it into a wire, you want it to be plastic because you want it to stay in that shape. So even though it's most ductile materials like copper, tungsten or whatever are ductile, are metals, they deform plastically. So the word plastic, don't confuse it with the material. It's a property of how things deform, and if they remain deformed after you remove the force, then we say that that's plastic. So lots of metals behave in a plastic way, and if they can be formed into wires, then we say that that is a ductile material. Good. So that's all of that row. Now let's see on the other one. Can be deformed plastically under compression and can be hammered into a sheet. So something that can be hammered into a sheet instead of a wire. Long thin shape would be a ductile material, but a sheet is more to do with a malleable material. So similar really in some ways to ductility, but here into sheets we talk about malleable. So what do we have left? We haven't found anything durable, we haven't found smooth, we haven't found stiff, and we haven't found hard. Let's see if the next four we can fit them in and they all make sense. So it's not readily scratched or indented. So something that's not easily scratched. You should have heard about the hardness test in the textbook. You have different degrees of hardness, and you place them in a table in order of hardness according to what material can stretch can scratch what other material. So this corresponds to scratching, corresponds with with hardness. What else? Since it requires a large force to produce a small deformation, so that's really talking about force, which is stress, related with stress, and deformation, which is related with strain. So this is something that produces, it requires a really large stress for a small strain. They're essentially talking on something with a large Young's modulus, and the Young's modulus size represents, as we've seen before, stiffness. So really this represents here stiffness. I'm nearly done, there's only one left, so let's see if it corresponds. We still haven't talked about, well, there's two left, sorry. There's durable and there is smooth. See, low friction surface. So if something has high friction, we call it rough. And if something has low friction, we call it smooth. So really, a low friction surface, we can just say, and I'm going to have to repeat colors because I'm running out. We can say the low friction surface is then smooth. So from here, we can bring it down there. Good. And finally, last one, properties do not worsen with repeated loading and unloading. And that's a material that's durable. So you can use it loaded, unloaded, loaded and unloaded lots and lots of times, and it doesn't really lose its properties. So that's a durable material. Just this one. And just as an add-on thing to say, when you give a small force or a large force, any force repeatedly, so that you stress it and unstress it and stress it and put a load and unload and like that very quickly on something, what you're doing really is a test called a fatigue test. So fatigue is repetitive oscillations on a material. So you do a lot of fatigue tests on bridges, for example, if you want to know whether the material is good enough to support all the trucks going through it every day, of different levels of vibrations and all kinds of different forces acting at different times. Then you do fatigue tests. So hopefully that makes sense. So just to go through it again, something returns to its original shape. That's something elastic. Something remains deformed when you take away the load, then we say that it's plastic. Something cracks and breaks without any plastic deformation, then we know it's not tough at all, it's brittle. The graph would then look like this. And then here it breaks, right? That would be the brittle material, where this is stress and that's strain. Or it could be extension and force. It just extends to a certain amount and then it just snaps. So that would be brittle. If it cracks and breaks with, yeah, that's the one, and then does not readily crack, can withstand dynamic loads such as shock or impact, then that's something tough. Something tough. It can take dynamic loads or an impact. It can take a lot of energy basically, and that's ones which have a large area under the graph. That would be a tough material. There's a lot of energy that it can absorb. If something can be deformed plastically under tension, it can be pulled into a thin wire. That's pretty easy. That's a ductile material. If it can deform plastically under compression and hammered into sheets, that was easy also. That's malleable. It's quite well known. If it cannot readily be scratched or indented, that's hard. You just need to know that it makes sense. It's related to scratch. Hard. then requires a large force to produce a small deformation. That's a stiff material, right? If you have a spring, then if you need a large force to stretch it to produce a small deformation compared with another spring where the force needed is much smaller to extend the same amount, then we say that this one has a larger stiffness than that one, right? And the same thing with wires or with whatever, we call it stiffness. And that's why the kx formula, this k is very often related with, is called the stiffness constant, because the bigger this k is, it means you need to make f much bigger to produce the same x. Hopefully that makes sense. And also just in talking in terms of Young's modulus, stiffness is represented by how easy it is to stretch something. So if it's got a high gradient, it means the force you need to put in is very high for a very low extension or strain. Strain is related to extension. And if the gradient is low, it means that you don't need such a big force to produce a pretty large strain. So then you say it's got a low stiffness. Finally, low friction surface, that's just a definition, we call it smooth, and that makes sense also. And then the properties do not worsen with repeated loading and unloading. That's a durable material, one that lasts from duration. Okay, so hopefully that helps with your the little exercise, and it didn't take you too long to do it or to look this up. And yeah, I would cut this up and paste it somewhere so that they're one next to each other and you can look at the definitions regularly. Alright. Hopefully that was useful, and I'll see you in the next video.